we have another thing which is called as sparse aware split finding. What do you mean by sparse data? A lot of zeros. If you have a lot of zeros in your dataset, like one hot encoding, etc., that is called as sparse dataset, or a lot of null values. Especially when you perform one hot encoding, etc., you'll get to see this. Okay. And there is something called as a sparse matrix. This sparse matrix is designed to store only the data points which have zeros and NA values. There's a special matrix which is designed to only capture the zero values and null NA values, or NA values and zeros, right? And those NA values and zeros are kind of ignored after that. Sparse matrix has a beauty of segregating your zeros from non-zeros, NA values from non-NA values, null values from non-null values. So the moment it segregates the zeros from non-zeros, NAs from non-NA values, etc., you can very easily store all the non-zero values and non-null values. And you can do away with all the zeros and null values. What does it do when you do this? It will, number one, save a lot of space. Number two, when you do the processing, you need not consider all those zeros and NA values. So the processing becomes faster. Okay. That is the reason why XGBoost is fast. First thing is it will do the imputation also automatically, so it will be fast. Of course, it is not storing all the zeros and non-null values, so again it is going to be faster. Okay, next. And there was a research which was done. There is a data set which is called as all state 10K data set. On this data set, when people experimented gradient boosting versus extreme gradient boosting, and then when they experimented by running different algorithms against extreme gradient boosting was 50 times faster than the next best algorithm. The next best algorithm out of all these experiments was, whatever be that algorithm, XGBoost was 50 times faster than that, based on research. So all these are the reasons why people are preferring this. Another thing is parallel computing. Is boosting ideal for parallel processing? Not at all. Because in boosting, the next algorithm depends on previous algorithm results. Okay. Then in that case, where will this parallelization be applied when it comes to XGBoosting? So what XGBoost does is it is going to compress and put the data in blocks. Now it starts making use of what? Your memory, your hard disk. It will start making use of your hardware, in short. Because logically you cannot do parallel computing because next algorithm depends on previous algorithm results. So the only way it can improve upon and bring in the parallel processing capabilities is by making use of your hardware. Because in algorithm logic, you can't do much. So the only way out is to look at the hardware. So what it does is it will compress the data and it will put the data in different blocks as opposed to sectors. Not sure whether you're aware of this or not. If I give you, say, 10 MB file, when you save it on your hard disk will have sectors. if you have say 2 terabytes data, 2 terabytes data of sectors will be there, and the sectors will be divided like this. I'm talking about operating system concepts now. Okay. When you want to save it, this 10 MB file gets split into 4 KB, 4 KB, 4 KB, etc. And it will get stored in different locations. Which all locations this data is getting stored is something which is again maintained separately as a file by your operating system. When you open this 10 MB file, all these 4 KB would be pulled out, and then you will see that file. Okay, this is how it works. So instead of storing the data in each and every location, if I can group certain blocks, then processing will be faster. Okay. And these blocks, rather than 4 KB, 4 KB, you create blocks of 4 KB, 4 KB, 10 4 KBs, create one block. All these blocks can be put on multiple computers. Okay, you can put on multiple servers rather, if you want to. Okay, and when you put on multiple computers, your different blocks, distributed computing also works fine. Okay. When you want to sort the data, individually, if you take everything and then sort it, versus if you take block and sort it, when you sort various blocks, it'll be faster. Simple logic. As opposed to sorting each and every 4 KB file, if you take a block and sort it or sort all the blocks, it'll be faster. Okay, so it is going to sort the blocks. Okay, so this is how it's going to make use of the parallel computing, because now it can work on different blocks in parallel. Working on every 4 KB file doesn't make sense. It'll be very time consuming.